Hi, I'm Jessica Lindsay. I'm a graduate student at the University of Washington, and today I'll be talking about quantifying characteristics of Natchiq lair habitat through knowledge co-production in Kotzebue Sound, Alaska. Now, this is part of a larger interdisciplinary project called Ikaviks to Cocoon, which is Inupiaq for ice bridges, and the project is located in the community of Kotzebue in the southeastern corner of the Chukchi Sea. At the start of this project, the PIs assembled an advisory council of 4 Inupiaq elders who are our co-authors, Bobby and Ross Schaefer, Cyrus Harris, and John Goodwin. And they worked together to co-develop a set of research questions that were of interest and of benefit to the community and figure out how to answer them together. And the question that we'll be focusing on is what snow and ice surface properties promote ring-sill denning and pupping. As folks in this topical session may already be familiar with, Natchiq are unique in that they give birth to their pups in snow-covered dens or lairs excavated in the snow above their breathing holes. And these lairs provide a warm and dry place that keeps pups protected from hypothermia and predation. And then later in the spring, the Natchiq will emerge onto the surface of the snow and sea ice to bask in molts. Now, although we know lairs are important, information in the scientific literature is fairly limited regarding what snow depth requirements and what duration requirements seals have for these lairs. And it's important that we get a better understanding of this given how rapidly change is occurring in the Arctic. We know that sea ice seasons are getting shorter, melt onset is occurring earlier in the spring, and in many places, snow depth is declining as well. Now, to quantify predictions for how these changes will impact Natchiq, we need to get a better baseline of what their lair habitat requirements are now. Our general approach for this was with 2 spring field seasons in 2018 and 2019 using a combination of on-ice and aerial data collection with continued involvement of the Elder Advisory Council throughout. For our on-ice fieldwork, we found Natchiq breathing holes and lairs at which we took measurements of the structure itself, as well as the surrounding snow characteristics. Between the 2 years, we found 50 structures, or more than 50 structures. And I want to look at one lair in particular that I think is interesting. So this is the lair as seen from the outside. And then if we look at the interior, you'll notice that there is a lot of seawater on the floor of this lair. In fact, there's 38 centimeters of liquid water on the floor, which does not fit our idea of lairs as a warm and dry place for pups. And we spoke with the elders on our Elder Advisory Council, and they said that in their experience, this is really unusual in the Kotzebue area and likely would be detrimental for pups. If anyone listening has observations of flooded lairs where you work or where you live, we'd be really interested to hear from you, so please send me an email. We also had the opportunity to survey a lair that we knew was being used by a pup. We didn't want to disturb the pup, so we conducted our survey on a day when we could see that the pup and its mother were hauled out at a different structure nearby. And we took measurements of the lair itself as well as the surrounding snow. Now, in the literature, typically the minimum snow depth that you'll see is 20 centimeters of snow on flat ice, with the idea that areas of rough ice will then accumulate deeper drifts where Natchiq can construct their lairs. However, in this case, the lair itself is in that 20 centimeter snow. From both the structure measurements and the surrounding snow measurements. And really much shallower snow than this, you wouldn't physically be able to fit a seal in that structure. So we have reason to think then that the habitat that we saw during our field season was perhaps at the margin of what is suitable for lairs. In addition to our on-ice work, we also conducted unmanned aerial surveys with Unoccupied Aerial Vehicles, or UAVs. And we conducted 6 flights over a 2-week period from late April to mid-May over 3 target areas that were identified in collaboration with the elders. This is a map showing those 3 locations. We were able to survey most of these 3 times. Our northernmost site, though, Sisolik, unfortunately broke away from us before we were able to do that 3rd survey. Those repeat surveys are interesting though, because you can see a lot of change in the same area if you survey repeatedly. So this is an image that our drone collected on April 30th, and you can just see that there's one Natchiq called out here, but then on May 9th, there are more structures visible, including here a lair with a Natchiq mother and pup, and also just more seals hauled out in general, likely for basking and molting. Now, as the UAV is doing those surveys, it carries side-by-side thermal and color cameras. And in thermal imagery, anything that is warm is going to show up as a bright white hotspot. And then that tells me to cue into the corresponding color image, and I can zoom in and confirm that it is a Natchiq, in this case, a mother and a pup. And over the course of our 2-week survey period in 2019, we detected over 1,000 Natchiq. And here I've plotted just one survey site on one day against a Landsat satellite image. And this is, the satellite image is from a stage of melt when most of the snow cover has melted away, and that highlights the underlying topography of the sea ice. So anything that is still white is are areas that have snow remaining, either because there were deeper snow drifts there to begin with, or because they're higher elevation and all the meltwater is flowing downward into low-lying areas. If I remove the path of the drone here, we'll see some interesting patterns in where Natchiq were detected and where they weren't. So it looks like we have high densities of Natchiq in these bright white and rough areas where we would expect there to be deeper snow, and then few Natchiq in areas of smooth ice and shallow snow. This led us to wonder if we could use the pixel values from the satellite image as a proxy for snow depth, since that's not something that we were able to measure directly from the UAV. To do this, I used generalized additive models and binned the survey effort into 250 by 250 meter grid cells. And within these grid cells, we used a couple of Landsat derived covariates. Within each grid cell, we computed the mean pixel brightness, which I'll just shorthand as brightness going forward, as well as the standard deviation of pixel brightness, which I'll now just call roughness. And we also included an interaction term between brightness and roughness, since areas that were both bright and rough were especially likely to correspond with deeper snow. And we also included a covariate for survey date, time of day, bathymetry or water depth, and wind speed, and used automated selection that automatically reduces covariates with weak contributions to Natchiq counts out of the model. So here we're looking at the effect of the covariates that the model retained on Natchiq counts. I do want to note though that these results are just preliminary. We're still refining the model and these results may change. But presently the model has retained brightness, roughness, bathymetry, and survey date, while it has dropped time of day, wind speed, and that interaction term. And these plots show the effect of these respective covariates when all the others are held constant and only each one in its given plot is allowed to vary. And the y-axis here is groups per kilometer squares. So in the case where there were multiple Natchiq hauled out at a structure together, that just counts as one. And these show that we have a weak effect of brightness, but higher Natchiq densities in brighter areas, and also higher Natchiq densities in areas of intermediate roughness. Now it makes sense that we would see fewer Natchiq in areas that are really smooth, but also that we would see fewer Natchiq in the roughest areas, since that is likely to correspond with bottom fast ice, where the sea ice is resting on the seafloor and there isn't water access for Natchiq from below. By that same logic, our bathymetry result makes sense as well, because Natchiq wouldn't be able to access areas that have really, really shallow water. And also it makes sense that we would see higher Natchiq densities as that survey period goes by, because more seals would be likely to be emerging from their lairs and spending time hauled out for basking and molting. We can also map the model's predictions with these bright red areas as areas that the model predicts of having the highest Natchiq densities, and the blue areas for lowest Natchiq densities. And I just have that satellite image over on the right for reference. So these bright red areas correspond with the areas of roughest sea ice that were likely to have had the deepest snow. And going forward, what we'd like to do is iterate on this model using feedback from the Elder Advisory Council, because they have knowledge of what the Natchiq distribution is like around Kotzebue, and we hope to use that to figure out ways that our model can be improved. We do know that the fitted densities from the model are generally lower than the densities that were observed in the aerial surveys, and there's likely lots of unexplained variation that we weren't able to account for, such as prey density or levels of human use. But hopefully, working together, we can refine the model more from how we have it now. We'd also like to produce a separate model for pups that were detected in the aerial surveys, and would also like to quantify the relationship between the satellite pixel values and on-ice data that we collected of snow depth and surface roughness that I wasn't able to get into today. But we'd ultimately like to convert those pixel values back as much as possible into more tangible measurements of snow depth and roughness, or to at least put bounds on those values based on what we saw on the ice. With that, thank you very much to the Gordon Betty Moore Foundation, who funded Akavik, as well as funders for my graduate research, and everyone who has been a great help on this project. Thank you very much.